Okay, let's do question 5 now. The function f is defined by fx is equal to 9 times 2x plus 3. For what value of x does fx is equal to 63? Okay, fx is equal to 63. That means we have to replace fx with 63, and this is 9 2x plus 3. Now here I want to solve this question with two methods. First method is like you apply the distributive property first, right? So 63 is equal to 9 2s are 18x plus 9 3s are 27, subtracting 27 on both sides. So this is 36 is equal to 18x. Now dividing by 18 on both sides. So 36 by 18 is 2. X is equal to 2. And another method is like, why not divide by 9 on both sides first? So all this distributive thing will be deleted, right? So 63 divided by 9 is equal to 9 by 9, 2x plus 1, 2x plus 3, that is deleted. 7 is equal to 2x plus 3, subtracting 3 on both sides and then dividing by 2 on both sides. So x is equal to 2. Both methods are correct, right? But this method is a little bit risky. Let me tell you why and what point you should consider while doing this. If I have like 63 is equal to 9 and 2x plus 3, so right hand side has two factors. First factor is 9 and second factor is this whole thing, right? So whenever we divide on both sides, the whole factor should be divided. If you are getting confused in it, you can leave that part, right? You can solve either by this or by this. But if you want to go in a little bit detail, then try to understand this. So here I can divide the whole factor like 69, 63 divided by 9 and 9 divided by 9. But if it is like 2x plus 3, right? So yes, 2 and x, this is 1 and 3 is added to. So there are two terms, right, which are added. So 2 is multiplied only with x, not with 3. So I cannot divide by 2 on this side like this. No, that is not possible. Because right hand side, this 2x is affected by 3 also. So you cannot do this. If you are dividing on both sides by some number or factor, it should be a complete factor, right? You cannot take a number out of two terms and then divide it. Yes, this is a factor, second factor. It has two terms, term 1 and term 2. So factor can have multiple terms, right? But if you are dividing, that should be a whole factor thing. Clear? If you want to leave this concept, you can totally leave that. You can adopt either method 1 or method 2. But in SAT, like, we must know every single aspect of uh, or every single way of solving the question. So every small concept is really important. So I suggest you to just learn this, but that is totally your wish. Okay. Sixth question is 10x is equal to 86. What value of x is the solution to the given equation? So we have to find the value of x. So if 10 of x is equal to 86, we will divide by 10 on both sides. So x is equal to 86 by 10. Now what this question is demanding or checking, it is checking, do you know how to divide with the power of tens or 10? So yes, what happens? Decimal moves to left hand side. So the rule is decimal moves to left hand side. Now you will say, where is the decimal in 86? There is no decimal. Okay. So 86, you can write it like this, right? By 10. And because there is one zero in the denominator, so this decimal will shift 1 point and that will become 8.6. Let's take another example. Suppose you have 86 by 100, right? So this hidden decimal is here, and because denominator is 100, you will move it 2 points, so that will become decimal 86. This question is checking our this concept. Okay, let's move to question number 7. Y is equal to 3600 a to the power x. So this is an exponential equation. Uh, the given equation, where a is a positive constant, gives the predictive number of bacteria y in a growth medium x hours after the number of bacteria was initially measured. Okay, as we can see, this is an exponential equation. So exponential equation is in this form, ab to the power x, right? So here, like, this is a function of x, so this is output, right? And this x is input. Whatever input you are going to give it, according to that output will be calculated. And in this question, it is about number of bacteria, right? So number of bacteria after time t is equal to 3600 a to the power t. That is about number of bacteria. And in this a is the initial value, right? You can ignore this part. I just try to, um, tell every possible way we can write or understand. So this a is the initial value. And initial value is like when you started the experiment, what was the original number? Now this equation is showing me that this 36 is 100 is the original number. Okay, let's see what is being asked. According to the equation, what is the predicted number of bacteria initially measured? So that means what was the initial value? 3600. So this question is only about how you interpret the equation. And do you know the meaning of every single term or factor or variable, whatever is given there? If you know that, then this question is just checking your knowledge for that. So initial value is 3600, right?